Hi everyone, let's take a second and look at a sample inclined plane problem. This problem is broken up into several sections, similar to how Regents questions are set up. First question is, what is the force of gravity? Second, what are the parallel and perpendicular components of gravity? Third, what is the force friction? Fourth, what is the net force? And lastly, what is the acceleration? So, for the first part of this question, let's discuss what is the force of gravity. So the force of gravity, if you look up in your reference table, find a question or an equation that reads gravity is equal to the force of gravity divided by mass. Now if you rearrange this to get the force of gravity by itself, you'll find force of gravity is equal to mass times gravity, the acceleration of gravity, in which case the force of gravity is equal to a mass of 10 kilograms times acceleration of gravity, 9.81 meters per second squared. That means that the force of gravity is equal to 98.1 newtons. Okay, so that's part one. As you might notice as we progress through these questions, the next piece is going to often require the previous piece to solve. That's not always the case, but you'll also find that on the Regents as well. A lot of the multiple part questions ask you to utilize the previous answers in that question. So for example, the next question reads, what are the parallel and perpendicular components of gravity? Well, we're going to need part one. So the parallel and perpendicular components of gravity look like this. Gravity wants to go straight down. However, this inclined plane is in its way. So a part of gravity is going to push this box down the ramp, like so. Another part of gravity will be pushing up against the ramp. We draw that as this kind of perpendicular vector going across this way. Now this is labeled as the force of gravity parallel, because the force of gravity parallel is parallel the plane. You can see these lines look like they will never intersect. Well, this purple arrow described as the force of gravity perpendicular because it makes a right angle along the plane. Now the equations that we use to find the force of gravity parallel go as follow. Force of gravity parallel equals the force of gravity sine theta. And to get the force of gravity perpendicular, we use force of gravity perpendicular is equal to force of gravity cosine theta. Now, just to be clear, if we were to take these vectors and rearrange them, you'll notice that their resultant is equal to the force of gravity. These purple vectors, these components of gravity, force of gravity parallel and the force of gravity perpendicular, they are the force of gravity. We just broke it up into components of this larger vector. So just like how if you took a x component and a y component, you use the Pythagorean theorem to find their resultant, it's the same concept. Take an x vector and a y vector, their resultant be the Pythagorean theorem, right? So like a squared plus b squared equals c squared. It's the same concept here, except it's at a slight angle because we're on an inclined plane. And we can't describe this as an x component or a y component because this is not the x-axis or the y-axis. Rather, this is an axis that's parallel the plane and an axis that's perpendicular to the plane. So it's the same idea, However, in this case, we're looking at an inclined plane, and we're specifically discussing or describing gravity. So let's substitute in some values and let's solve. The force of gravity parallel is equal to the force of gravity, which we calculated to be 98.1 newtons, times the sine of 20 degrees. The force of gravity perpendicular is equal to the force of gravity, which we calculated to be 98.1 newtons, times the cosine of 20 degrees. And if we solve, we get 90, let's clear this all out. As you can see, I did some checking. 98.1 times the sine of 20 degrees gives us a force of gravity parallel equal to 33.6 newtons. So this value over here is 33.6 newtons. And if we move the force of gravity perpendicular back to its original position, and punch this equation in again, but rather use the cosine of theta, cosine 20 degrees, we will get force of gravity perpendicular equal to 92.2 newtons. And hopefully this should make sense. If you think about it, this is a small incline, right? Most of gravity would be on the perpendicular side, this region right here. Since it's only a small incline, only a small force will be pushing this block down the incline. So when you solve for these values, hopefully you put them into the context of the question, and if you made a mistake, you can identify that mistake quickly. So for example, if I found the force of gravity parallel to be 92.2 newtons because I accidentally used the wrong trigonometric function, that would seem like quite a large value for such a small incline. If this read 92 newtons, that's almost the entire force of gravity. For a very small incline, that is quite a large number. I would want to guess, or I would want to recheck that response. Okay, so let's take a look at the next part of our question. What is the force friction? Now, if you refer to your reference table, the force friction reads as the following equation. Force friction is equal to mu, coefficient of friction, times force normal. Now the normal force is the force of the floor pushing up on the object. In this case, the floor is an inclined plane, and it's not pushing straight up, but rather perpendicular to the slope. So if we go up in a perpendicular direction, right? This is perpendicular. Go up in a perpendicular direction, you'll notice that this arrow is approximately, well, if it was better drawn, same size as this arrow. See if I can rotate this. It'd be great. Yeah, awesome. Great. So now I adjusted it a little bit to make it the same size. That is the normal force. So the normal force is equal to the force of gravity perpendicular, which in this case is 92.2 newtons. So let's put in some values. We calculated the normal force to be 92.2 newtons. Let's look up the coefficient of friction in our reference table. So to pull that up, the approximate coefficients of friction We need to consider if it's kinetic or static. And also we need to look at the materials of within the system. So kinetic means that something is sliding already. Static means that something is still. Let's assume that our box is already sliding. So let's refer to the kinetic friction. And let's also review our materials. We have wood box on a wood inclined plane. So a wooden box on a wooden inclined plane would have a kinetic coefficient of friction of 0.30. So our mu is 0.30. We multiply 0.3 with 92.2 times 0.3. Get an approximate answer of 27.7 newtons. 27.7 newtons. So that's the force resisting the change in velocity. That's the force that's resisting movement. So it looks like this. Notice this arrow is smaller than this one. That is intentional because the value is smaller than the force of gravity parallel. So the value of force friction, the one that's resisting the movement of this box, is equal to 27.7 newtons. The next question reads, what is the net force? And the net force is the sum of all of these vectors. So for F net is equal to the sum of all of these forces. So if we add up these forces, let's take gravity, let's take the normal force, and let's take friction. Gravity, we divided into two components. So let's look at gravity in these individual components. So the force of gravity parallel and the force of gravity perpendicular. Now the force of gravity parallel is on the same plane as the force of friction. Notice there, these things are basically at the same exact angle. So we can simply just add them. So if we look at the force of gravity parallel and the force friction, let's say that up the hill we'll just describe as positive. So we'll attribute a positive value to the force of friction, 27.7 newtons. And down the hill is a negative value, so we'll attribute a negative sign to the force of gravity parallel, which is 33.6 newtons. 33.6 newtons. And if we take these two values and find their sum, 27.7 minus 33.6, we get negative 5.9, or a direction going down the hill. The net force, F net, is equal to 5.9 newtons and looks like this, approximately. If it was drawn to scale, it would actually look more like this. .9 newtons. Now, we didn't discuss much about what was happening with these other values. So let's take a look at the force of gravity perpendicular and the normal force. Now, force of gravity perpendicular, 92.2 newtons down into the ramp. The force of gravity, the force of normal is 92.2 newtons up onto the block, perpendicular to the ramp. Since they're on the same angle, the same plane, and also since they're the same value, we can add those up as well. the force of gravity perpendicular, and the force is normal. Let's do positive 92.2 for the normal force because it's going up, and negative 92.2 newtons for the force of gravity perpendicular because it's going down into the ramp. You'll find that that perpendicular component is equal to 0 newtons. And these parallel components we calculated to be 5.9 newtons. So since there's nothing happening along the perpendicular axis, we can just refer to the parallel axis, and that would give us the actual F net. If there was an unbalanced force along the perpendicular axis, it would look something kind of like this. And if you have an arrow going parallel and an arrow perpendicular, you have to rearrange these a little bit. And then you can, oh, it's not letting me, that's okay. You can rearrange it this way. And then you can use the Pythagorean theorem to find the resultant of a triangle that's A, side B, and side C. Because these would make a right angle. But I've never seen a question, or Regents level question, where you would have to do this. So chances are your F net will be equal to the sum of the parallel forces, 5.9 newtons. Lastly, what is the acceleration? To find acceleration, it's hard to pick a color now. To find acceleration, we can look at our reference table and you'll see that acceleration is equal to F net divided by mass. And we have F net. Acceleration is equal to 5.9 newtons. We were given mass. Mass is 10 kilograms. If you take 5.9 divided by 10, we'll get an acceleration of 0.59 meters per second squared, going down the ramp. Now, this is a more involved inclined plane problem. Rarely will there ever be a 5-part question on a Regents, but hopefully this thoroughly explains how inclined planes work and the things to consider when solving for inclined plane problems. I hope this helps. Let me know if you have any questions. Take care.